I'm Jack, this is Zach, and this is our design notebook for our One Small Step program, project. We did this project, and throughout it we had a design notebook, which was each steps that we had to follow to complete our project. And the first step was identifying the problem, and that was design a payload that can shield astronauts from space radiation. This whole project was for NASA, and what they are trying to do is develop a way to shield their astronauts from space radiation, specifically the Van Allen belt on the way to Mars. So step 2 was identify criteria and constraints, and they had a long list. We've kind of condensed it for you. It had a minimum height, or a maximum height, weight, and depth, and width, which was 7 inches for each, for height, width, and depth, and 7 pounds for weight. And step 3 is brainstorm possible solutions. We did a ray shielding lab, which tested which paper would be best at blocking visible light out of tissue paper, copy paper, tagboard, and construction paper. And tagboard was the best by far, so we thought we might be able to use that. And we watched some videos put on YouTube by NASA, and it said that hydrogen is really good at blocking radiation, or space radiation, because it's not very reactive. Like lead would actually be very bad here because it's extremely dense, which means there's a lot of molecules in it that would react with the rays. So water, I thought of using water because water is made up of hydrogen and oxygen. And our idea was initially that we could put a bag. We were testing. What our test was, we had an emitter that emitted UV light and some beads that would glow if it was hit by that. So we thought, so we were trying to get the beads to not glow. So we put them in a bag of water and put that inside a box of tagboard that we have here. Our partner unfortunately wrote on it and also did not show up to make this video. So this was our initial design. It's not amazing, but it worked. And our practical of actually what we thought we could submit to NASA, we didn't have the money to buy this stuff, was a graded Z material shielding, which would have higher density materials scaled down to lower density materials to block that. And boron carbide, we thought if we could use as just like a single material shield because it's one of the hardest materials after cubic, boron nitrate, and diamond. And because boron and carbide only have 2 valence shells, they're low Z materials, so they wouldn't be as reactive. And selected design was, we had a blueprint of our box. Build a model or prototype was actually building the box. We had steps to do it and a materials list. And we had several tests that we did. One of them was seeing if burning the tagboard would affect how much it blocked the UV light, and it didn't. Another one is soaking the tagboard in water, since water is another thing we were testing, and that didn't affect it. We actually thought it might make it better, but it didn't really seem to have any impact. And the last material was a durability test. So we had our box, and we also made a cylinder of tagboard. Here's the blueprint for it. And we continually stacked textbooks on these, and eventually the box started to crumble. That's why it's a little bent here. But the cylinder held up for a while, so we changed our design to a cylinder, and put the bag of water in that, and that also worked. Step 7 was refine the design. That's basically what the tests were for, and our refining was changing the design to a cylinder because it was sturdier. And step 8 was share our designs, and so that is actually this video right now.
Mitchell Reed, report to the Dean's office immediately.
So yeah, that was this video that we were doing.
Michelle Goulis, please report to the main office. Michelle Goulis, please report to the main office.
Sorry. Alright, so. Yeah. Anyway, so what we would actually submit to NASA is, again, boron carbide, because it's a low Z element. It also has a very high melting point of 2,645 degrees centigrade, and it won't scatter particles as much as other materials like lead or titanium. And with its high melting point, it wouldn't be as affected by the heat from the sun. That was our project. So thank you for listening to it. We're sorry for the interruptions from the intercom. Some people were doing bad stuff. Thank you.